In Chapter 2, we're going to be looking at different graphs, and the first one we're going to consider is broken line graphs. Now, graphs are a great way to analyze data. So when you have a bunch of data, just looking at the numbers, sometimes it's a little overwhelming. You throw it up on a graph, and suddenly you're like, oh, so that's what that all means. So we're going to work with doing that. Some important things to know is that whenever you're graphing something, make sure you have the title there and that you've labeled the horizontal and vertical axes. Without that labeling, we have no idea what that graph actually means. So you have to decide what variables display on each axis as well as a scale for them. So that's just, what is it going up by? Is it going up by 1 each time? Is it going up by 5? Is it going up by 1,000? It could be whatever, an appropriate scale. Your independent variable goes on the horizontal axis. So when you have a graph like this is your independent variable. And that means the thing that doesn't, it just kind of goes on its own. Often it's time, because we can't control what time is doing. It might be the number of things that are being sold or something like this. And this is the dependent variable on the vertical axis or the y-axis. So we could say the distance somebody's traveled depends on the number of hours, the amount of time they spent traveling, for example. So we would label it that way, not dependent, independent, but say in that case this would be distance traveled. And I'm just going to do it briefly, distance traveled. You'd write that horizontally, and this would be, or pardon me, vertically, and this would be time. And you have to decide on units, so maybe we're doing hours here, and here we're doing kilometers, and maybe we're going up by 100 kilometers each time. It has to be the same between each. Maybe this is 1 hour each time, etc. Okay. Broken line graphs, you would plot certain points, and then you would have a broken line in between these points. So maybe we've plotted a point here, one there, there's another one there, maybe another one there, and we're just going to connect it with broken lines. Now let's look at our first example. So here we have the average snowfall in Regina, Saskatchewan by the month. So in January they had, it looks like almost 20 centimeters. In February they had less, so around 14. March it was up again. April dropped way down. May, June, July, August there was no snow, not a big surprise. September there was 1 centimeter, a little more in October, more in November, December. Anyone who's lived in the prairies for a while is not surprised by this graph. So which month has the highest average snowfall? Well, highest average snowfall, so we're looking at the snowfall and we're looking at which dot goes the highest. Well, that would be December. And how much snow fell that month? Well, we look on this line, looks like 21 centimeters. It's going up by 1 for each tick. 21 centimeters fell. Okay, during what 3 months is there no snowfall in Regina? We already talked about that. That would be June, July, and August. And during what month is the average snowfall approximately twice as much as the average October snowfall? So let's see, what's the average October I can't say that. Snowfall. Well, this is 5 centimeters, so 6. This is 7. So twice that would be 14. I go over here, there's 15, so 14 would be along this line here. I go, and oh look, February looks like it's 14. Whoops. But if I look also, November looks like it's about 14. So I could say both February and November, and if you just picked one of them, that would be fine, have approximately twice as much.